Hello my dear students, welcome to my YouTube channel that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel and press the bell icon to get the regular updates of the upcoming lectures. My dear students, today we are going to derive the formula of percentage ionic character in a covalent bond with the help of dipole moment. Please do listen to the lecture very carefully. Let's move to the screen. So, we are going to study now percentage ionic character in a covalent bond. So let's drive it with the help of dipole moment. In the previous lecture, we have done that. What is dipole moment? I'm writing dipole moment. What's the formula of dipole moment? It's is equal to the delta, that's the magnitude of charge that has been separated, into bond length. Now, if we know the exact values of the dipole moment and the bond length, we will be able to evaluate this delta. And this delta is very important in finding the percentage ionic character. So, let me take an example. I am having A which is bonded with B with a single bond. Now, let's assume B has higher electronegativity than A. So that means B is going to attract the shared pair of electron towards itself, thereby B will acquire a delta negative charge and A will acquire a delta positive charge. And here we are concerned only with this delta charges, not with their sign. We are concerned with the magnitude of this delta charge. Now, what's the highest value of the delta that it can be achieved? That's A, B, and the highest maximum value possible for delta is E minus and E plus. What's E? What's the value of E? The value of E is 4.8 into 10 raised to power minus 10 electrostatic units. So, now it's very easy to find the percentage ionic character now. I'm writing the formula. Percentage ionic character will be equal to the magnitude of charge separated divided by maximum value of charge that can be separated divided by maximum value of charge that can be separated whose value we have evaluated to be 4.8 into 10 to the power minus 10 ESU now into 100. By this way, we can evaluate the percentage ionic character, and the value of delta, the magnitude of charge separated, is obtained with the help of formula of dipole moment. Now, let's solve an example. The dipole moment of HBr. The question is the dipole moment of HBr is 1.2 dBi. Now, full stop. If the bond length is 1 angstroms, if bond length is 1 angstrom, full stop. Find the percentage ionic character. So that's our numerical. The dipole moment of HBr is given to be 1.2 dBi. And if the bond length is 1 angstrom, we have to evaluate the percentage ionic character. Now, in the previous lectures, I have told you about the conversion factor of dBi to the electrostatic units. The conversion factor is 1 dBi is equal to the 10 raised to power minus 18 electrostatic units centimeters. So that's the conversion factor of 1 dBi, and that's 10 to the power minus 18 electrostatic units centimeter. Now, here bond length. Here bond length is L, which is given to be 1 angstrom. That means it is equal to the 10 raised to power minus 8 centimeters. So the bond length come out to be 10 to the power minus 8 centimeters. That's the conversion factor for angstrom to the centimeters. Now, let's put the value of dipole moment over here. Sorry, the formula of dipole moment over here. The formula for dipole moment is mu is equal to the delta into bond length. Now, the dipole moment is given to be 1.2 dBi, which is equal to the delta, and bond length is given to be 1 angstroms. And we have to convert all these units in CGS system. In the first lines, I have given you the conversion factors. So now let's convert it. Now 1.2 dBi comes out to be 1.2 into 10 to the power minus 18 electrostatic unit centimeters, because the conversion factor of 1 dBi is 10 to the power minus 18 ESU centimeter, which is equal to the delta, and we have to convert angstroms to again CGS, and 1 angstrom is 10 to the power minus 10 to the power minus 8 centimeter, and it comes out to be 10 to the power minus 8 centimeters. From this point, we have to evaluate the magnitude of the charge, that is delta, and it comes out to be 1.2 into 10 to the power minus 18 into 10 to the power plus 8, and it comes out to be 1.2 into 10 raised to power minus 10 electrostatic units. So from this formula, from the formula of dipole moment, we got the magnitude of charge, that's 1.2 into 10 to the power minus 10 electrostatic units. So we got the value of delta. So now let's put this value in the formula of percentage ionic character. Now that's percentage ionic character, and it is equal to the, what's the value of delta, divided by 4.8 into 10 to the power minus 10 into 100. So we got the formula of percentage ionic character. Now let's put the values over here. What's the value of delta? That's 1.2 into 10 to the power minus 10 divided by 4.8 into 10 to the power minus 10 into 100. It comes out to be 25%. So that means the bond between H and the Br. H bond Br. This bond is 25% ionic in nature, or we can say it is 75% covalent in nature. So that's all for today's lecture. I hope you all understood the derivation of percentage ionic character in a covalent bond with the help of dipole moment. So that's all for today. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please do like, subscribe and share this channel to maximum number of students. Stay blessed.